Hello everyone. So in this video we are going to discuss about a question which is eco. This question is based on band research. So let's approach the question. The question is very simple. It says a lumberjack Mirko needs to chop down m meters of wood. It is an easy job him since he has 90 new wood cutting machine that, that can take down forests like wildfire. However, Mirko is only allowed to cut a single rows of trees. So the question is very large. I can explain you easily what the question is says. A Mirco machine works as follows. It has height parameter h in meters, and the machine raises against a blade that height and cuts off all trees and higher than h. So you can read all this. I am going to explain what the question is. So it says there are multiple trees. Let's suppose trees. There are multiple sizes of trees are you have available. Okay. You need to cut all trees using a saw blade at a particular height edge. Okay, you need to cut all trees at a particular edge, and you need to give the maximum amount of wood which left after the cutting the trees at height edge. So just like what is the maximum amount of wood? Okay, let's suppose if you cut your trees at this height, then their maximum amount of wood will getting decreased, and you decrease if you cut at height at this height, then there will be a very less maximum amount of wood. So maximum amount of wood is continuously decreased as if you increase your height. So the question is very simple. We can solve this question using predicate function. So first of all, you need to know what is predicate function. Predicate function is a function which is uh, which is true, and at certain point it becomes it start becoming false in a monotonic way. Then it is a predicate function. So it can be a at starting true, it can be a at starting false, and at a certain point it becomes false. Just like okay, just like at this point, if you maximize your height, if you cut trees at height at maximum, then you can see the maximum amount of wood will become zero, means it returns false. So we need to find the point at which the maximum height of true is available. Okay, the maximum height of true is available. So for we need to find at a point at which the maximum height of tree is available. So for finding the maximum height, what we gonna do is simply we finding the middle element. Okay, just like we just take middle element. If it is lies on true, then we search onto then we are then we need to search for the maximum true, which must be lies onto their left. So we can say if our middle lies onto a if middle is true, if middle is true, then it needs to search onto a left part. Then we just mark our mid becomes low and high as it is. Okay, and high as it is, and we again calculate mid, and if mid is again less than the maximum true element, then we again do this. Okay, so as like if our element just like if our trees return false, just like if our maximum amount of trees height is returns false, then we need to search onto a right path, and we need to give the maximum amount of wood will possible. So it must be point on this region. So we just mark our middle element becomes high. So we can say high becomes middle, and we again calculate middle element. And after middle element, if it is again lies onto a right path, then we again calculate mid, and at certain point that mid becomes high, and we just return that maximum amount of O. So the question is very simple. I think you are understand the question. So let's approach the question. So question says, so first we need to take the input of the questions. So the input is for the first line of input contains two space integers, and the n represents the long integers. Okay, and m is the most required odd amount. This is on the range of to the power 2 into 10 to the power 9. So it is a long integer. So we need to take number of integers. Take long, so we can take as 1 is 6, 1 is 6 plus 1, and integer and m will be. So n is we need to take the number of trees as input, which is we need to declare number of trees, and we need to declare what is the maximum what is the maximum wood amount. So we can say it must be in log m, because the value is maximum. And after this point we need to take an array. We need to take an n space separated positive integers. Okay, heights of trees. So we need to take as height of tree as input in array. Say trees as input as array, and after this we need to take as input after taking as input what it says the constant value and declared. So after taking input for number of trees and the maximum wood, we need to take the input for our arrays. So arrays I can say, and since take the input of arrays. After taking input, we need to find out. First, we need to find out where the trees lies. Just like you can see in this time, we need to find out where it lies. It lies in this region or not. So we need to make an first. We need to find out where no pointer lies. So it lies at the first index. At the zero index, we can say it is at 0, and our high is at, you can see high is at big number. Okay, it is, you can see here it is already mentioned that the maximum required amount is very large. You can see. So as this point, our high will be point as maximum number. So I can say 1 e power 16, or 6 is a very maximum number. So this point at 10 to the power 6. So after low and height, we need to check if we need to check if it is lies in the area or not. Okay, and after this, if it is lies onto a middle path, if it is returns true, so we need to make a predicate function. Predicate function will just tells it is we just tells what maximum number maximum amount of what height you need to require for maximum number of wood. So we can say it must be in boolean, and we can say this time maximum wood in h. Okay, we can say the maximum height. The maximum height, the maximum will be. So our maximum wood is like this, and we cut at a particular height h, and if any trees the maximum amount will be becomes more, then we just add this maximum amount into our wood. Okay, so for doing this, at first we are marking at wood at 0, and it at certain point, if any trees if any trees are if any trees the maximum amount of wood is greater than h, then I simply says okay, I is not understood. So at certain point, we need to first goes in trees, and at certain point, so at certain time, then our wood just killed the trees, just at the difference. If certain amount would just add the difference about the maximum difference about current trees and height. Okay, if it is height of the tree is h, the height if the whole tree is I represent and it is height, so the maximum amount of wood will be there, their difference will be this. So we can say the wood plus will be trees of I minus h. So while we are doing this, I just says give the result after. Okay, return when our wood will be greater than maximum height. Okay, return that wood value. It is a very simple when you would okay. So this time I check. Okay, if I minus 2, if our predicate function return true, so I says if our maximum would returns true, then we need to search for a more maximum true, then we need to iterate into our right part. So for iterating onto right part, we need to make our uh, current true to low. Okay, our low becomes the current true, and we again search for mid element, and if the mid element is not the current maximum, then we again search onto a right path and we do again and again. So the approach is very simple. So I say where max wood is and I so for this we need to calculate the middle element first, which is high plus low by 2, high plus low by 2. We need to declare middle element, okay, which is this, and when I plus 2 at some point, if maximum mode of mid is true, it is a max maximum wood. Okay. If not return true, then we need to search for middle part. So for searching mid becomes low, and else if any false comes, then we need to search for a right path. So we can say high becomes mid. For searching on right path, then our mid becomes high, and we need to search onto a left part, and we need to give the two element. So at most the false comes, we need to just give here one element precedence of one element. So we can say mid minus one. Okay. So at this point height returns mid minus one. After all of this, we need to check if the current element, if the current maximum amount of trees returns to, if the middle returns to, then what happens? So for this we need to write case if our maximum would return, if our mid becomes high, if our mid becomes high, then simply print at high, or else condition simply print low. Okay. As we can say, our code is ready to check. If our middle element is high, you can say, then simply print the value of maximum amount of tree wood, and if it is at low, then print at low. Let's see it is runs or not. Okay, so our input is, just see the test cases. It says the input is 4. Right now runs. Are we taking the properly or not? Okay. Okay, I have in 4 and 7 input, and 20, 15, 10 and 17 is an array. You can see it returns 15. If you check about the next test cases, then we can say number of trees is 5, the number of trees is 5, and the maximum wood amount I required is 20, and the trees height are 4, 42, 40, and 26, 46. Okay, and you can see it returns 36. So our code is ready. Just submit it and check if it is passed all the test cases or not. So thanks for today, guys. This is for today. We are coming back on to our new next video. So see you later, guys.